Fantastic. Christina mentioned we would start with the poll. And so over the next few minutes, I ask the audience, please, to participate by answering this question. And we've given you 4 options. Which statement best reflects your view of ceramic ultrafiltration today? A niche solution for difficult applications, technically superior, but still too expensive, approaching broader economic viability, or finally, a future mainstream platform technology. And so I ask the audience, if you would, over the next few minutes, reflect on that and select one of those options here to help us out with this poll. We'll greatly appreciate your input. We all know water systems are under increasing pressures. There are a variety of structural pressures creating impacts on water systems. Aging infrastructure the world over. The planet's going to need longer lived assets. Probably one of the most not talked about challenges, and I'm going to share some data with you in a minute about this, are workforce shortages that are coming, and they're coming fast. We're going to have fewer experienced operators. We were having a discussion a week or so ago with one of my colleagues, and we were talking about growth in reuse. It's interesting to think that wastewater and the ability to reuse water is actually the only growing source of new potential water. And so reuse is going to require more demanding treatment options. Obviously, source water quality is declining. We're all aware of PFAS challenges. We're all aware of microplastics challenges and a number of other challenging operating conditions. Reliability demands, this ties directly to workforce. Downtime is a killer. And then ultimately capital constraints. We've got to continue figuring out how to do more with lower capital budgets. And that's true for industrial and municipal users. So there's a greater focus on lifecycle costs going forward. I wanted to unpack some of these key structural pressures a little bit more and share over the course of the next 10 years, it's expected that there will be over a 40% gap in the supply and availability of water suitably purified for whatever its intended use versus what is actually available. I also wanted to share that the workforce is retiring. Operators in water treatment plants in the US, for sure, US EPA expects somewhere between 33% and 50% of all current water treatment plant or water treatment equipment operators to retire in the next 5 to 10 years. As that workforce retires, we're not backfilling. We don't have younger people coming into the workforce to fill those jobs. And that's going to create a tectonic shift in how the industry values water. And we need to be thinking about technologies that are much more resilient, that have a much higher on time, and that require not as great of a super trained workforce in order to keep those assets operational when fully a third to half of the workforce is expected to retire in the next decade. And then finally, just pure demand growth, over 25% on the low end. All of this data, by the way, comes from the UN, UNESCO, World Bank, US EPA, and a variety of industry market forecasts. And so this is not Cerafiltec data. This is data that our industry is, and challenges that our industry is facing writ large. So why advanced membrane solutions are becoming essential? Well, if water demand is going to be up 25%, we've got to have the ability to extract more value from every gallon of water that's treated. If we're facing over the next decade a water supply gap exceeding 40%, then reuse becomes a strategic water source. If we've got a third to half of our workforce retiring, simpler, more resilient systems become critically valuable. And ultimately, technology advances are creating new demands. Reliability matters much more than increasing capacity. So, technologies and solutions that were optimized for problems of the last 50 years are maybe not the right solutions for the next 50 years. And if the world is changing and the dynamics are changing, then shouldn't we also be changing the types of technologies that we're looking at deploying to address these problems? So, an interesting thought. What if the industry is actually using outdated assumptions about ceramics technology? I'll be very curious to see the results of the poll. Hopefully, you've all had a chance to vote. But ceramics, historically, I believe there's a view that ceramics perform well, but their adoption has been somewhat limited due to economics. There's a view that they're just expensive. And so, what if today's ceramic ultrafiltration economics justify mainstream infrastructure adoption? Before I get into some specific economic and ROI calculations, I wanted to give you just a super brief overview on membrane filtration. What are ceramics, their structure, the materials of construction, and operating principles? Well, everyone's familiar with multimedia filtration, sand filters on one end of a spectrum. On the other end of a spectrum, you've got polymeric nanofiltration and reverse osmosis. Ceramic filtration typically is a very highly porous, sintered either alumina, dialuminum trioxide, or silicon carbide. And so those are the materials of construction. And their operating principles generally fall into one of two categories. My colleague Amrit is going to talk a little bit more about this in a minute, but those two categories include submerged, low pressure, outside in filtration, or high pressure filtration. And so the performance advantages for ceramics include high durability. Those ceramic materials tend to be quite inert. Therefore, they're very resilient to extremely low pH, extremely high pH operating conditions. They're very easily cleaned in place and returned to acceptable operating conditions, owing to their chemical resistance and thermal resistance. They have very stable performance. And my colleague Amrit is going to share several real world examples with you and actual data that underpin this notion of performance stability over the long term. And finally, because of all of those capabilities, they tend to have a very long operational life. So what we do here at Cerafiltec is we focus on submerged outside in flow, and our solutions are scalable to your needs. We start with a ceramic plate. It's a sintered ceramic. Our preferred material is alumina or dialuminum trihydroxide. We take these ceramic plates, generally put 34 of them into a single filtration module. Although we have some flexibility, we don't have to use 34 plates. If in a particular application, we needed to take some of the plates out to create more space in between the plates for greater flow, we can do that. And then we stack those filtration modules into what we call a tower. Now, as a practical matter, we could put as many as 16 modules into a single tower. You notice in that image, we put some feet on it to give it a little bit of a lift off the bottom of the tank to allow flow underneath. And then we attach some headers, generally a sprinkler system at the top. This allows us both to collect the outside inflow permeate as well as enabling very easy CIP during normal operation. And we can put multiple of these tower configurations into a tank or multiple tanks, depending on a particular need. And so it's a very scalable, low pressure operation, submerged outside in filtration technology. So I mentioned a minute ago, what if the industry is overestimating the cost? What if ceramic ultrafiltration has actually achieved a cost structure that makes it incredibly competitive with incumbent traditional filtration technologies. And so I wanted to share some return on investment data, long-term data, that really illustrates how ceramics are outperforming uh, alternatives. Measured over time and across a variety of applications, ceramics are consistently outperforming polymeric systems, and even, depending on the application, multimedia filtration systems. We generally see a 5x or better lifetime of these systems. And over the course of that lifetime, much fewer needed membrane replacements. And so if you unpack those beneficial economics, we generally see up to 40% less energy requirements in order to operate ceramics. We see up to 60% less maintenance. And certainly from an ESG metrics perspective, if you calculate the environmental CO2 footprint, ceramics are delivering 40% less impact. Obviously, this is becoming an increasingly important and visible topic for civilization. So the longer life, the lower energy demand, reduced maintenance, deliver measurable OpEx and sustainability gains, and that improvement truly speaks for itself. And so what I want to suggest is the industry may be overestimating the economics gap. Ceramics no longer carry a multi-times cost premium compared to traditional filtration technologies. Independent studies are showing that even CapEx comparisons on the front end only differ by maybe a few tens of percent. And so therefore, the life cycle economics are beginning to matter much, much more. You have a much less frequent need for replacing the modules. You have superior cleaning tolerance, much greater uptime, and that uptime is critically important, particularly when we think about what's happening with our workforce. Ultimately, the ceramics are delivering a considerably better lifetime. And so it's an interesting thought. I can't wait to see the results from our poll. I hope you've had a chance to vote. And I just wanted to, as I prepare to close here and hand it over to Amrith, giving him a chance to walk you through some real world applications, I just wanted to share some benefits versus traditional filtration, and really want to have you, as you absorb this slide, want to have you think about that question. And the question is, if traditional filtration technologies were optimized for challenges of the last 50 years, and the world is changing, then shouldn't we be optimizing our filtration technologies that we're deploying today for the challenges of the next 50 years? And we believe, for a variety of reasons, ceramic filtration in particular delivers on that need to optimize for the challenges of the next 50 years. So I wanted to make a couple predictions as my last page before I hand it over to Amrith, because I'm certain you're going to want to hear from him on several real-world deployments and the resulting data from them. My predictions on ceramic technology going forward: what matters the most? The old way of thinking was CapEx. And the new reality is that life cycle costs are going to become much, much, much more important. We've talked about, and I've shared some data with you. You can go out and look at independent sources that I shared as well on the workforce. The old thinking was that it was manageable, but when fully 1/3 to 1/2 of your workforce is expected to retire in the next 5 to 10 years, this becomes a very, very critical constraint in the new reality. Water reuse is a significant source of water for the future. The old thinking was that reuse was a niche area. And the reality, as we face the future, is that reusing water is going to become a growth engine for us. Reliability is tremendously important. In the old way of thinking, it was nice to have, but it is absolutely essential going into the future. And so finally, ceramic ultrafiltration. Historically, interesting technology, but perhaps specialty. We believe going into the new reality, it will become an infrastructure platform.